Good morning, all. I see people are joined around 16,
Morning, sir.
17 is there. Yeah, good morning.
Good morning, sir.
Good morning, sir.
Morning, good morning. So I see some lot of people are joining now. So I just waited for just 5 minutes extra. That's all. Was about to start by 11 and something. It's going on. Anyway, I'm happy to see that the people are there for even for now BGP and the MPLS. Because the whole world is moving towards the cloud and automations, Kubernetes, Docker, Ansible, and other things. But still, people are looking for a BGP and MPLS. I like this because I'm basically from this. This is my core skill, I can say. I started my the career on routing switching only. I'm a routing switching CCIE. So MPLS was part of the. A later part, it has been added to that routing switching papers and all like. So we've been working on MPLS also, BGP also extensively. And I've been supporting in the bigger ISPs, internet service providers, for quite a long time. I was being involved in the Cisco also. I've been working for Cisco for 5 years now. So I have a long history of routing switching, and it is my core skill. Still, I used to maintain bigger networks, and I speak about this also. And I used to design some networks on the routing switching, MPLS platforms, and data centers, data center interconnectivity, and ISP interconnections. Means like from Indian ISP will be connecting to the London ISP, like a BT, they will be having a connections. French Telecom will have a connections. Sprint and AT&T and other people will be connecting from the Tata VSNL, Reliance Jio, Bharti Airtel. There's a long history of that, and I would like to say that ISP environment cannot avoid the MPLS. It's not possible for them. Now there is a lot of new advancements has come up even after the MPLS. Also, MPLS has been tried to be removed from the major part of the ISP, and they are trying to do that also, but still it has been relying. It's been lying on that, and segment routing has come up after that MPLS. And once the cloud has come up, the people are not looking for, mostly they are not looking for any MPLS connections because cloud is doing a lot more than MPLS. We'll be seeing that MPLS, what is the advantages and disadvantages of this. How was the things has been started with an MPLS connections. Previously, it was ATM connections were there and frame relay connections were there. And nobody is using ATM as such. When I was doing the MPLS itself, the ATM has been completely closed, and the support has been removed from Cisco itself. Like that, long history has been there for MPLS and BGP. BGP cannot be avoided by anyone. I'd like to stress on that. So without BGP, your interconnectivity will not happen at all. You just need to configure some peer groups, attributes need to get configured. Networks need to get advertised. So if you like to reach the internet, you require an MPLS. Sorry, you require an BGP, definitely. So BGP is a border gateway protocol, and how BGP is involved with the MPLS connections. Because BGP is mostly utilized only within the internet service providers cloud, and MPLS also. MPLS is given from the ISP cloud people only, like VSNL MPLS cloud is there, Reliance MPLS cloud is there. Everyone was CFI MPLS cloud is there. Spice has got some cloud on their own. Every other ISP will be running their own MPLS clouds, and they will have a interconnectivity between their own clouds all over the world. So it's a very long history about BGP and MPLS. We are going to talk about something on a BGP and MPLS. And maybe like this session maybe for an hour or something like that. But I used to conduct so many sessions on this one, like 5-day session on MPLS, 5-day session on BGP, something like that, because it's a very high requirement from the ISP people and the heavy supporting people like larger banks like JPMC, JP Morgan Bank, and many other foreign companies as well, MNCs. I used to deliver the training over there. Training in the sense it's like a sessions I used to conduct for them, like because they are already been working on MPLS and BGP. But they would like to have some scenarios need to get discussed. If the people would like to go for a CCIE, Cisco certified networking expert. So nowadays been clubbed, so many things has been added extra to that routing switching itself. Service provider cloud, service provider certification has been a lot of modifications has been happened. New certifications has come up on the CCIE like data center certifications, and DevNet has come up, development and operations. That's a DevOps. So these are all like you can take it as like an evolution. Entirely removing the MPLS is not possible as far as I think, as far as I know, I can say, because there is a huge money involved, huge investments has been made on that MPLS cloud, and it has been still running successfully on many places. And we've been offering to the many people on the MPLS clouds. So it is not entirely, it is not possible for us to remove it. At least one other connection, they'll keep it on like an MPLS, like a what do you say, business, something is a business continuity plans, BCP plans will be having it. So they'll be having like MPLS, sorry, they'll be having the broadband connection to the internet. They'll be having kind of, the lease line connection to the internet is MPLS connections to the internet. Like that, this is how the bigger networks will be connecting to the internet. Because even if you like to connect to the cloud services like AWS or Azure or Google Cloud or something like that, you require the internet connections. Internet connections, if you like to hugely, would like to transfer your network suffix, sorry, prefixes to the cloud provider, in the sense you require to configure the BGP. And the BGP should be knowing that, you should know the BGP very well. Then only it will be deployed in the data centers, high data center, heavy data centers and all that. Even though we are talking about like, MPLS VPNs, we are talking about MPLS layer 2 VPNs, layer 3 VPNs, you know, and nowadays we are talking about like a SD-WAN connectivity, software defined WAN connections and all. So everything we can include that in the MPLS itself. MPLS was giving a lot of room for development as well. And it's not like a proprietary or something like that. MPLS is a technology. And, there was a protocol that's been used on an MPLS and all. Like, so as far as the network engineer is concerned, like, it should be equipped with all the knowledges whichever it is being there in the current market. Current market is moving towards the cloud and the cloud operations and cloud administrations, cloud automations and other things. But even in the cloud also we do a lot of networking. Without networking, we will not be able to do any kind of resource utilizations or resource allocations or connectivity between the on-premises and to the cloud and the private data centers to the cloud. Everything is possible. The connectivity remains as a core. It's like a platform. So without the core, the people will not be knowing about it. It's in the backbone. Okay, the backbone is not there. Nothing is going to work out. So we require BGP. So we require MPLS. Like that. So we can take it in that way. Like, but the MPLS learners, I can just say that MPLS, the people who would like to come up and start learning in MPLS, means it's been reduced a bit compared to the SD-WAN connections and other things, segment routing and all. I'm planning to do some segment routing also, maybe coming up in the sessions or something. I try to do that because segment routing, I just need to have some kind of an XRs. I just need to configure some iOS XE and other things. We will do that also, not a problem. So MPLS has been giving the room to get it developed towards the segment routing, and it's been giving the room for the SD-WAN connections as well. In SD-WAN also we can have the MPLS connections on that. So it's a long history, I can just say, about BGP and MPLS has been clubbed together and it's been offered. So whenever the BGP has been implemented on the MPLS cloud, it's called as an MP-BGP, like multi-protocol BGP we call it as, right? So BGP, we should start with it. Later we'll go for an MPLS, means like in this session I'm telling. Then later we will be having some small, small lab which I constructed on my GNS3, which I will be showing you. This is a diagram I would like to show you. So there will be on a customer end, this is on a customer end. This is in one city and another city like that. So he is connecting to the PE1 in the sense like provider edge one. And this provider edge one is connecting to the provider inside the cloud. You can say this is a cloud inside. And this provider is talking to the another PE2, like that provider edge 2. In the provider edge 2, the CE2 is being connected. Means the customers, another location has been connected to that. So you can take it as like CE1 is in Bangalore, CE2 is in Singapore. The CE1 will connect to the local ISP, means like either Spice or VSNL or something. They'll connect to the MPLS cloud on that. So VSNL will have as Singapore Telecom like that, SG Telecom as So they will have MPLS connections in between. Then they have their cloud form. So the same customers, remote end will be connecting to the remote end will be connecting to the peoples on the Singapore side or something. So we will see. This is a very simple example I would like to show you because we don't have much time for that. And okay, let me go through the slides. It's very important. People are looking for that. Anyway, let us start with it now because I see some couple of people have joined more also. So thanks for joining all, and I've been conducting these sessions on every Sunday 11 o'clock without fail. Any new technologies or any older technologies, or even if you would like to have to hear from me like some other technologies which you would like to have some kind of more knowledge or something like that, you can just get back to me, and I'll be giving you my numbers and WhatsApp numbers and Gmail address and other things. I'll give it to you, and I'm running
It
my
would be
YouTube
every Sunday
channel.
7 a.m.
Hello.
Yeah, it would be every Sunday 7 a.m.
It's
Right?
actually 11 a.m. 11 a.m. Indian time. I'm doing it on
Okay, 11 a.m.
11 a.m.
Okay,
Every Sunday 11 a.m. on IST, Indian time, Indian Standard Time. I'm doing that. Okay.
okay,
So you
okay.
can join
Nice.
me, no problem at all. Even if you get a mail or a notification from my side, nothing in it. If you don't get anything, just come on 11 o'clock. You just click on the link, you'll be getting it. Okay, don't worry about that. Okay, let us go to the topics. Let me make my
Hi Ramnath. Hi Ramnath.
yeah, good morning. Yeah.
Hi, good morning. Do you provide any FI training or something like that?
Definitely, I have a sessions on LTM, GTM, and ASM. All three sessions I posted on the YouTube. You can watch it freely. There is a 3 hours demo has been there on every topic.
Oh,
Watch that.
what is the YouTube channel? Can you please tell me
YouTube
the name?
channel is there, and I will give you in the last slide. It's there. I can just say, or otherwise, you can go to the youtube.com/cc for channel and /Ramnath Kesav. That will be the one. I will type it on my, the Zoom chat, so you will get it. It's there. It's there. It's there. Everything is there. No worries.
Okay, thanks so much.
That'll be coming up. No worries. I'll give you. I guess it's not coming up. No way.
Okay,
I
no,
guess
no issue.
minimized it. No, maybe. Okay. Anyway, I will. Ramnath Kesav. You can just search it in YouTube. You'll get it. Okay. Let us go to the BGP today's topic, and let me make this bright. Okay. So concepts and terminology. Okay. BGP terminology, concepts and operations. Let us go to this. Why this is not showing? Close this guy. Resume slideshow. Okay, let us start like this. So this is about that. Would like to tell you something on the basics on IGP and EGP. Before starting that BGP, IGP is called as an interior gateway protocol. EGP is called as an exterior gateway protocol. Interior gateway protocol and exterior gateway protocols. People who are coming from the routing switching background, they will be understanding this is a very basic things on this, and so this routing protocol operating within an autonomous system is called as an IGP. And this IGP is examples I can just say RIP, OSPF, and EAGRP or IGPs. Wait, this is not coming as a full thing. 1 second. Let me share it again once more. Give me 1 second. Yeah, now it's coming clear. Okay, great. So you can just see that now it is an IGP versus EGP. We are talking about that. IGP means interior gateway routing protocols, interior gateway protocols, I can say. And the exterior gateway protocols, it's an EGP. Routing protocol operating between the different AS and EGP. Routing protocol within an AS, it's called as an IGP. BGP is an inter-domain routing protocol and it is an EGP. EGP means exterior gateway protocol. So BGP has been utilized in both the ways. One is for inter AS also, as well as intra AS also. Intra means the same AS. We can use it, but normally we will be using the BGP for exterior gateway protocol only. Means like when we try to connect two different continents, two different kind of customers from the different countries as well. Like definitely we need to use the definitely we have to use the BGP protocols only. BGP is a border gateway protocol. So this is the diagram which has been showing on this. On the left hand side, we are just seeing that an autonomous system is a 65,000 is been there. On the right hand side, it's like a 5,000 it is there. You can just see the difference on this. So this difference is nothing but the number difference is there, 65,500, and this is 65,000. So this difference makes to work with, we require a eBGP. That is called as an eBGP connection is required. So this is quite common thing. It's not a bigger issue at all. So let us go to the next one. Autonomous system. What is an autonomous system first of all? Autonomous system is a group of routers that share similar routing policies and operate within a single administrative domain. Group of collection of network under a common administrative domain is called as an autonomous system. Autonomous system has been given as a numbers. That's what we were seeing in the earlier 65,000 and 65,500 something. An AS typically belongs to one organization. A single or multiple interior gateway protocols may be used within the AS. In either case, the outside world views the entire AS as a single entity. If an AS connects to the public internet using an exterior gateway protocol such as BGP, then it must be assigned a unique AS number, which is managed by IANA. Unique AS number. Unique AS number in the sense we just need to purchase that AS number, then we'll have to connect to that. Your ISP will be taking care of that. We just need to purchase it from them, or they will be doing it some kind of an arrangement so that they will be advertising your networks under certain AS number on that. That way it's been done. The next, these are all the regional internet registries. Registries in the sense, who will be the internet authorities for certain regions. Region in the sense, I'm talking about the geographical locations of the continent wise I can take. Afrinic, that is nothing but a continent of Africa. The link is afrinic.net. APNIC, that is an Asia Pacific Network Information Center. We come in this region, means India comes in this region. India, Singapore, Sri Lanka, Pakistan, Bangladesh, even you can say Malaysia, and all I can just say Hong Kong, until that I can just say. So that is an applic.net. ERIN is an American registry for internet numbers. Canada, US states, US, and several islands of the Caribbean Sea and North Atlantic Ocean. That is an ERIN.net. LACNIC, Latin America and Caribbean. That is nothing but a South America we can call. Central and South America portions of the Caribbean. LACNIC.net. RIPE, that is for Europe and Middle East and Central Asia. That is Central Asia in the sense is China and Russia will come into this RIPE. RIPENIC, we call it as. LACNIC, ERINIC, APNIC, AFRINIC, RIPENIC. So these are all the people who are authorized to give the, the autonomous system numbers for us. So we just need to get the autonomous system numbers from these people. But actually we will be getting it from our local ISPs only. The ISPs will be having the contact with this RIRs, regional internet registries. So the AS numbers can be between 1 to 65,535. That is nothing but a 64K. So normally we say like a 64K. 64K is nothing but our 65,535, the number comes. RIR manage the AS numbers between 64,512. Why? Because 512 to 535 are the reserved private use. We can use it for our own laboratories and all. We can use these private numbers on this. IANA is enforcing a policy whereby organizations that connect to the single provider use an AS number from the private pool. That's what I was saying. For all your local laboratory environment, we can use the private AS numbers. And even more, if you are not afford to buy a public AS number, and ISPs has got kind of a peer group and like private AS numbers and all, like they have some kind of a confederations and other things. There is a very high fund. So those are all like they will be giving you the private AS numbers. You can configure that so that you can connect to their ISP network. From there, they will be routing it back with their own public AS numbers to the outside. Like that it is happening. Note, the current AS pool of addresses is predicted run out of 2012. 2012 is 8 years out. So we are already been on that. They are looking for like a 16-bit numbers for this one. Like for this reason, IETF has released RFC 4893, some RFC numbers, and they would like to bring it to the 32-bit, like 4-octet field. Like that, it will be like the size will be like from this one. Currently, we are using the 16-bit. That may be going into the 32 bits like that. It's like an IP addresses we will be writing on this. So still we are not going into that one. We are using this within the numbers only on this till now. So maybe like in future, maybe 2 to 3 years or something like that, we'll be using those numbers also. 32-bit numbers of the AS numbers, it's possible. Next one, BGP basics. Internet is a collection of autonomous systems that are interconnected to allow communication among them. BGP provides a routing between these autonomous systems. BGP is a path vector protocol. What is a path vector? What are the other protocols are there? Other protocols we can call it as like a normally DV, distance vector protocols, link state protocols, hybrid protocols, right? These many protocols are there. So hybrid protocols is like an AGRP. Link state is an OSPF and ISIS. Distance vector is nothing but RAPE and IGRP and other people. So these are all, we can call it as an IGP only. So, but BGP is like a path vector. It determines the path. Actually, it is coming from the, what I say, distance vector family only, but it is using its own algorithms and it is using the TCP as a communication. And it has been using like a lot of attributes to finalize the routing informations and other things, how to reach the certain autonomous system or something. So it is only the routing protocol to use the TCP. Rest all what are they using it? We will see them later. Okay. OSPF and BGP, EAGRP operate directly over IP. ISIS is a network layer. So everything has got its own characteristics. RIP uses the user datagram protocol of the transport layer. It's a different information they are giving it. Like so, BGP is the only thing it is directly using the TCP. TCP 179, that is a port number which is used for BGP connections on the connecting between the peers and neighbors and other things. So let's go to the next slide. Number of current BGP routes. See, I taken this yesterday. I taken this, 9th January, I guess, yeah. See that 6th Jan and 4th Jan 2021. Yesterday I took this one. So as of 9th January 2021, there are 4,65,201 routes in the routing table of the internet core routers. You can just see that. So updated prefix count, you can see this area, I just need to see that. So this many routes has been populated by the internet core routers. Internet core routers in the sense ISP people who are configured for their customers to connect to the internet. So those core routers are having this much of routing tables are populated and they are still growing. This is very much in growing. If you compare that with the 2 years back or something, the prefixes, whichever it has been, the prefix in the sense I am saying about the routes. Prefixes which has been were very much lesser, but nowadays it has been keep on coming up. You can also go to this link and you can see what is the today's count. This link is, you can just click on this link and you can go to that. Anyway, I will share this PPT to you. You can also check it out. Not an issue. So BGP is the key. BGP is the core. BGP, without BGP, you will not be able to connect to internet at all. So BGP cannot be removed by anyone. And moreover, BGP is an open source. Means like nobody is owning the BGP protocol. Like everyone can integrate it to their own operating systems or something. It's possible. Next, BGP operational overview. When two routers establishing a TCP enable the BGP connection, they are called neighbors or peers. TCP enabled the connection. There is a connectivity has been there between the two BGP neighbors. So when they are connecting with them, like there is a series of handshaking will be done on this. Last state will become like an established. Established in the sense the connectivity is being maintained by the two neighbors. Like that. So that is a TCP enabled BGP. That's what this is called as a neighbors or peers. Peer routers exchange multiple connection messages. We will see what all the messages are there. Each router in BGP is called as a BGP speaker. Is going to speak about his own networks, his own prefixes. Like many other things are there. BGP is a bigger ocean that it cannot be discussed in just in half an hour. But you can just try to pick it up with a small tumbler of water from the ocean or something like that with these sessions. So now you can just see this is entirely 65,500, sorry. And this one is a 65,000 AS. There's a two different ASs are there. So this router BGP C and the router A, they are called as eBGP neighbors, I can say, because they are talking to the two different autonomous system numbers. And these are within the same autonomous system number. So I can just say them, these are all iBGP neighbors. These are all iBGP neighbors, and these two are eBGP neighbors. eBGP neighbors, like, let me clear this because so much of a check has happened. No problem. So this router A will not become a neighbor to the B because it is not directly connected. Not directly connected. Only the directly connected neighbors will become a neighbor. Only directly connected neighbors on the only directly connected routers on the BGP will become the neighbor. So these are all the BGP neighbors. That's what the arrow mark is saying, that C and A are the BGP neighbors, and A and B are not the neighbors. These are all neighbors. BD as neighbor. D has got a two neighbors like a B and C, like that it goes. So whenever they have the TCP connections complete, and they will be calling it like they can become a neighbor, or they will be called as like a peers, something like. So let's go to the next slide. Comparing the IGPs with the BGP. Protocol, interior, exterior, type, hierarchy required, metric. What are the metric the protocols are using it? RIP is one of the protocol, very much small scale integrations which we can do that. Maximum 15 only it's possible. 15 locations we can connect on that. So RIP is a routing information protocol. It's an interior gateway protocol, and the type is a distance vector. Hierarchy required, it's not required for a hierarchy. Metric is like a hop count. How many hops are the jumps? How many jump it can make? Packet. It can go until only the 15. So that is the maximum is called as a 15. 15 hop counts it's possible. 16 is counted as an unreachable like that. OSPF, it's an interior. Its type is a link state, and it is hierarchy required. Yes. Metric is a cost. Actually speaking, there is no limit for the hop counts until like that. No limit as such. But here as an ISIS, it's an interior link state only. Hierarchy required as. Metric is like a metric only here. AGRP, advanced distance vector, and it's a composite metric has been used. BGP is an exterior gateway protocol by default, and it is a path vector has been used, and the metric is going to be the attributes we call it as. We'll see what all the attributes are there in the next coming slides. So this is just like a comparison between the IGPs, known IGP protocols with the BGP. Using BGP in enterprise network. Enterprise network, definitely you should be working with the enterprise network on a BGP connections only, otherwise it's not possible. When BGP is running between the routers in different AS, it is called as an external BGP. When BGP is running between the routers in same AS, it is called as an internal BGP. This is internal BGP, 65500, and this is an eBGP. eBGP in the sense, this C and X is having a connection called as an eBGP because they are in different autonomous systems, and the Y and D is having the eBGP connections because and this is a different autonomous system numbers. So let's go to the next slide. Internal BGP. Internal BGP neighbors are the same autonomous system numbers. Means iBGP neighbors do not need to be directly connected. It's not required to be connected to the directly connection or something like that, but they still, they are in the same autonomous system number only. And these iBGP neighbors, these are all the iBGP neighbors, I can just say that. But here it is like eBGP neighbors, it's called. So BGP need to be learned properly. What is an iBGP? What is an eBGP? How the neighborship has been formed? What are the messages are sent? Which protocol has been used to become a neighbor? What are the parameters we can configure for that? And how to advertise the prefixes to that? And what are the attributes we can configure to influence the routing, between the autonomous systems and or something. So it's very big. That's what I was saying, that it's a bigger ocean. Anyway, we will see something. external BGP. eBGP neighbors are different autonomous systems. They need to be directly connected. They should be directly connected. They will become the neighbors like. So this we've seen already. When to use BGP and when not to use BGP. This is most important because BGP is a CPU consuming and memory consuming protocol because it will be doing a lot of calculations inside the router where it is running the BGP protocol. Inside the router in the sense the router where we configure the BGP will be doing thousands of calculations, metric calculations, attribute calculations, algorithmic calculations that will make the CPU intensive as well as the memory intensive for that. So the router may go slow, and whether it is very much required or something like that, we will be configuring a BGP on a router. If you are going to configure a BGP on the router in the sense, it requires to have more CPU as well as the memory should be more for that. Then the BGP can run without any problems on this. So this is like a suggestion has been given for that. When to use BGP most appropriate when the effects of BGP are well understood and at least one of the following condition is existing, then only you should be using the BGP. AS has multiple connection to another autonomous systems. AS allows the packet to transit through it to reach other autonomous systems. Example, if it is a service provider. Routing policy and routing selections for traffic entering and leaving the AS must be manipulated. So these are all the three major categories. These are all the three, like main points for the BGP should be configured in a location like that. So when not to use the BGP, do not use BGP if one or more of the following conditions are existing. A single connection to the internet or another AS, it's not required at all. You can just do the static routing is enough. It's a direct connection. And lack of memory or processing power on edge routers to handle the consistent and the constant BGP updates. Definitely, I was explaining the same thing. You have a limited understanding of the route filtering and a BGP path selection process. If you are not eligible, if you are not educated about the BGP selection process and other things, because it will be very heavily intensive and it will kill your router itself or network itself. That's why you should be having a proper understanding of this BGP. So you do that. So in these cases, use a static or default route is enough. That is more than enough. So where we will be using the BGP, if we have multiple connection to the another AS, and the AS is allowing the transit to the another AS as well, like a service provider routers and all. And the routing policy and the route selection for the traffic leaving, entering should be configured like that. Then we'll be using the BGP. Else, we will not use the BGP. We will use only the static route or default route. That is more than enough. BGP tables. What are the tables the BGP will create? Every routing protocol will create a table. Say, for example, if it's a AGRP will create 3 tables. One is a neighborship table, another one is a topology table, and the last one is a routing table. So like BGP is also creating its own tables. BGP keeps its own table for storing BGP informations received from and sent to the BGP neighbors. This table is also known as BGP table, BGP topology table, BGP topology database, BGP routing table, and the BGP forwarding database, like that. So the router offers the best routes from the BGP table to the IP routing table. Beautiful. First, it will be creating a neighborship table. Like any other protocol, it will be creating a neighbor table. List of BGP neighbors we can able to see in that. Then the BGP table, that is the forwarding database, you will be having all the prefixes will be listed. List of all networks learned from each neighbor. Can contain multiple paths to the destination networks. Contains BGP attributes for each path. Then the IP routing table. List of the best path to the destination networks. From the BGP table, the routing table will be created. Best of the path will be pushed to the routing table so that the router will be following that path to send the packet to the destinations. So BGP is also creating 3 tables. One is a neighbor table, BGP table, routing table. So it's quite common with all the all the protocols. So BGP will also be doing the same. What are the message types? There are 4 different BGP message types are there. One is an open message, update message, notification message, keep alive message. Every message will be conveying certain informations to the neighbors, peers, or another autonomous systems accordingly. Open message, update message, notification message, keep alive message, So these are all the octets, like how they are, what all the things are involved in this when it has been sending that information to the other guys. So what all the information it is carrying in the one message it's showing. Path attributes. Path attributes are the set of BGP metrics describing the path to a network. That is nothing but a route. BGP uses the path attributes to determine best path to the networks. Some attributes are mandatory and automatically included in the update messages, while others are manually configurable. That's why it's like a mandatory or non-mandatory, something other people just do. BGP attributes can be used to enforce the routing policy. We will be creating a routing policy also. And configuring BGP attributes provides administrators with the many more path control options. Example, filter routing information, prefer the certain paths, customize the BGP's behavior. These all been constructed as the path attributes. What all the path attributes are there, we will see in the next slide. Attributes are here. Some attributes are mandatory and automatically included in update messages, while others are manually configurable. So these attributes are used by either eBGP or ABGP, like that it's been used on this. So AS path is another attribute. It's called as a well-known mandatory attribute. It's can be configurable in eBGP also, IBGP also, and it has been automatically included in the update message. Next hop attribute, it's also well-known mandatory in both the cases, eBGP and IBGP. Origin, well-known mandatory, automatically included in the update messages. So these three, AS path, next hop, and origin, these three are automatically included in the update messages. Local preference is it's not allowed in the eBGP. We will be able to configure it in IBGP only. This is coming under the well-known discretionary. Atomic aggregate, well-known discretionary. Aggregator, community, multi-exit discriminator. This is called as a metric. So this can be configurable to provide the path control. So these are all like mandatory things. These are all transitive, non-transitive, discretionary. Means like a manually configurable, and it can be advertised by manually. Like that we can just do that. So these are all the attributes. Attributes and communities need to be learned properly so that you will be saying that I know about BGP. Like that I can just say. So it is not like overnight you can learn the BGP. If someone is saying that, please don't believe that, because BGP requires very rigorous practices and you should be working on a real live network to understand the BGP. How does it working on? Minimum 5 to 6 years to understand the BGP operations and other things. And moreover, you should be involving any designs as well for bigger companies to get participated on the ISP network, or like an MNC which is connecting to the local data centers and which they will be connected back to the cloud. Now the public clouds are there. Like when you are doing like a large scale cloud integrations as well, then you will be understanding the BGP on this. Okay, but it will take its own time to understand all these things. And how the route selection process is happening. This is a lengthier procedure. Nobody can remember this by heart. Like in CCA exams and all, they just ask these questions. Okay, for examination purpose, what we do, we'll just by heart and we'll go. And the next 1 hour, it will get erased from the memory itself. So this is how it has been given. Like a highest weight is taken first. Let me make it as like a numbers here. You will understand this. So this is preferred weight. Then the local preference is number 2, and the locally generated network, that is number 3. AS path is number 4. Origin is number 5. There are 13 will come around, like med is number 6. eBGP, IBGP, eBGP over IBGP 7. Closest IGP neighbor. Prefer eBGP route, and prefer route to the lowest neighbor router like 10, and route with the lowest IP address, neighbor IP address, something like that. And it has got some weight attributes also, like that they included on this one. So like around 11 is coming up. We'll not be able to buy out all these things, but we just need to have it. Like we need to have some lookup. When you are going for an interview or something like that, they'll be asking you this definitely. Some kind of notifications you can make it on your hand or something, so you can just say that. I don't recommend that, but still I'm telling that, because even if you go for an exam or something, it's very harder. So there are two places where you can avoid by hearting this. You cannot avoid this. I'm telling, one is for an exam, another is for interview selection process or something. Anyway, nowadays it's all happening on the telephonic only, so you can you can even keep this list pasted on some your cube or something like that. You can see and say it. Okay, anyway, this was just for a joking or something like that. But you just need to understand that what is the preferences of how the route has been selected. You can identify that how the route has been placed on the routing table based on these criteria only. So to understand this, to understand the routing table, it will take a lot of time for you to understand, because you just need to go through with this list. Then you will understand that how the route has been placed on that line. So it takes time. So if you're working on, keep on working on the BGP and working on a multiple pages and pages of the routing table outputs or something, you'll be able to understand that maybe like 3-4 minutes or 5 minutes or so it may take. So you just need to do a lot of filtering to understand the route selection process. So one is weight, local preference, network aggregate address, AS path, origin, MED, IBGP route, IGP neighbor, EBGP route, oldest EBGP route. You see that? So something like it's happening on this. And let's go to the next slide. Configuring the BGP. How do you configure the BGP? BGP configurations, we are doing it here on the 3 routers. These 3 peers are configured with the BGP. There is nothing but an internal BGP. IBGP has been configured on these 3 routers. ABD. ABD is having the IBGP connections. It's an IBGP connection. We are there in the same AS number. And the C has been configured like an EBGP neighbor because he is in a different AS number. So A and C will be form the EBGP neighborship. EBGP, G has to come. Okay, EBGP neighborship, and these 3 will be forming the IBGP neighborship on this. How to configure that? Configurations will come like this. B router will be configured. The router BGP. This is autonomous system number has to be given. Neighbor should be specified mandatorily. Remote AS is nothing but what is the remote AS number of that person. Means like what is the peer AS. 10112 AS is only 65101 because it is belonging to the same AS. So in the D router, it is not actually, it's not given. So A router, we can check that. In the A router, the local AS number is 65101 and the neighbor address is 192.168.1.1. That is the address of C, which is the remote AS number is 102, 65102. And one more neighbor is also there. It is like a 10112, something like that it goes on, which is the remote AS number is a 65101. That is a D router, like that it goes. So this is how we will be, configuring this. You should be understanding that. It's a very simple one. And in the C router, how do you configure that? Router BGP 65102. That 102 is nothing but the local AS number, which is should be configured on the C. That is what been given. And the remote AS number is nothing but the AS number of the A. AS number of the router A. That is 65101. So once you make these configurations properly and the connectivity has been maintained properly in the sense, you will be able to see the neighbors on C as the A will be shown. In the A, you will be seeing the neighbors of B, D, and C also. It will be shown. So you can see that all the things. And next one, BGP states. This was I was telling about the states. BGP is a state machine that takes a router through the following states with its neighbors. First, it is idle, connect, open send, open confirm, established. Idle state begins once the neighbor command is configured. Means like when we configuring this is the order of execution. Like idle, then connect, then open send, open confirm, established. This diagram you can just see that one. Where is the 2 connected? Right? Where is the 3 active? Where is the 4 open sent? 5 is open confirm, 6 is established. Like that it is. In between the keep alive and notification and everything will be sent on that. So to see the output of the BGP summary is nothing but like it's a neighborship relationship. You can just see that. So this is what the BGP, the R1, the output has been coming up. It's showing the router identifier RD is nothing but a 10111. We can configure the RDs for the BGP. Local AS number is 65001. BGP table version. This will, the table version will be always keep on changing whenever there is a modification happens on this. Main routing table version is 124. 9 network entries. How many learned and local something is there, which is occupying how much of a memory? Either 1 GB, sorry, 1 MB it has been taken on this. And 22 path entries. They're using 1144 bytes of memory. 12 of 5 best path, BGP path, and best path attributes. It's all concerned about the memory only. 6 BGP AS path entries in the non-44 bytes, right? So here you can just see the list of it. Neighbor list 10102. 10102 is the first neighbor, 172.31.13 is the second neighbor, and 172.31.11.4 is another neighbor. Like that it goes. So there are 3 neighbors there. So because of this guy is in 65,001, I can just say this guy is an IBGP neighbor, and these 2 are EBGP neighbors. You can see that. How many messages are sent, how many are received between the neighbors, what is the table version, how much has been left out in input queue and output queue, how long the neighborship has been running successfully. That is what the timing it has been shown. Seconds, minutes, seconds, hours, it will be going like that. How many prefixes are received and sent? That will be shown. So this will be giving you very nice details about that. But if you are having a more neighbors which are connected to the real level confusions, you just need to see it properly. Next, show IP BGP neighbors. This command will be giving you the detailed neighborship relationship between the peers on this. This is one of the neighbor which is showing. So when it is coming like a BGP state established, you see the yellow color, something is there. So when he's saying it is like an established in the sense, like they are able to exchange their routing informations, path prefixes, and everything is possible between them. So this is the last state of the neighborship making. So it will be giving like all the how many messages sent and see like each and every neighbor it will be giving like. So now you just see that this is showing is like an external link. External link in the sense it's an EBGP neighbor. The R1 is having the EBGP link, EBGP connection with 172.60.31.1.3. That is what the meaning of this. So that has been established and it is up for 19 minutes and 10 seconds. So like that we can just see this. And the next one is an IP BGP table. This BGP table is very important. When it is coming into the BGP table only, it will go to the routing table. So the order of preferences will be like this. First neighbor, then BGP table, then the routing table. Like that. So the second table is a BGP table. BGP table will be having so many informations. This legend codes, we just need to see that. These codes are there, no status codes, suppressed, damped, very sorry, suppressed, damps, history, valid, star is a valid, and greater than is a best, I is an internal, R is a rip failure, A, S is a stale, like that it goes. Stale route means it is not working at all, like that. So you can just see the legends over here, the first 2, 3 are columns available. So by just seeing these codes, you can identify what is that. So for example, I can just say this is a star and greater than. Star and greater than in the sense valid and best route. So this route will be placed in the routing table. You can just see this in the routing table as well. Like that, you can just see one by one. If there is no greater than is not there, best is not there, it will not be placed in the routing table like that. So we can just learn that by one. Here there are so many other things. So the star means the next hop address is valid. Minus R means read failure. Greater than is the second column, indicate best path for multi-selection, your selection. Like that, keep on happening. So they explained everything very so beautifully. You can just go through one by one. Better if you do the practice and you're learning on these things, that will be nice. Rather than just learning something on this one, okay? The next is like, let us go back to the MPLS things. So this is until that we've seen some BGP. MPLS is a multi-protocol label switching. Multi-protocol, that's what. It's a label switching. It is taking the packet to the layer 2, then it is started switching, doing all these things, not based on the routing table or something like that. MPLS is an efficient encapsulation mechanism. Uses the labels appended to packets, IP packets, WAL5 frames for transport of data. MPLS packets can run on other layer 2 technologies such as ATM, FR, PPP, POS, and Ethernet. Packet over SONET, point-to-point protocol, frame relay, synchronous transport, something like that. We can do in anywhere on the MPLS packets can be running. Other layer 2 technologies can be run over the MPLS networks. Labels can be used as a designators. For example, IP prefixes, ATM-BC or bandwidth guaranteed path. These are all the labels we'll be calling it as like. MPLS is a technology for delivery of the IP services. So MPLS has been provided only by the ISP people, MPLS providers. We just need to take up the like a service like how we are doing it, the services we are taking it from the Amazon or cloud like that. MPLS is also one of the service we just need to take it up. And like it goes like a contract based like that, how long you would like to utilize the MPLS connections or something. We will be paying it accordingly. So apart from this, we will be seeing certain technical things on MPLS on this. Original motivation of the MPLS: allow the core routers networking devices to switch packets based on some simplified header. It's from theory. Provide a high scalable mechanism that was topology driven rather than flow driven. Leverage hardware so that simple forwarding paradigm can be used. It has evolved a long way from the original goal. Hardware became better and looking up longest best match was no longer an issue. By associating the labels with the prefixes, groups of sites or bandwidth paths or light paths, new services such as MPLS VPNs and traffic engineering, GMPLS are also now possible. These are all old things. So okay, these are all the motivations of the MPLS. What all the terminologies are used on this? PE, that is a provider edge router. P is a core router, provider core router. CE is a customer edge router, also called as a CP. ASBR is autonomous system boundary router that we use it in the OSPF. RR is a router plugger. T is a traffic engineering. VPN is a collection of sites that share common policies. ATOM, any transport over the MPLS. Commonly known scheme for building the layer 2 circuits over MPLS. Attachment circuits, emulated circuits, like that we can just use that. But we just need to know the acronyms of the PE, P and C mostly, like we should understand this. Provider edge, provider core, customer edge. These are all the three terminologies which are used commonly in the so we can see some of the concepts on MPLS. So there is a bigger diagram which has been there. MPLS has been provided from the cloud only. So that's why whatever it is there inside the cloud, we can just call it as like these are all the P routers. And these are all you can just call it like a PE routers, the outer edge like this. At the edge, classify the packets, label them, label imposition like this. Here in the core, forward the using the labels opposed to the IP address. Label indicate the service class and destination, label swapping and switching. At the edge, remove the labels and forward the packets. LSR, that is called as a label switch routers. So like in the core, we'll be seeing the P or LSRs, we can call it as like. So label distribution protocol, that is a LDP protocol which has been used for to distribute the labels between the neighbors, and they will be every other prefix will be having attached with a new label for that. By the label numbers only the prefixes are identified, and the best path has been identified for that. Create new services via flexible classification, provides the ability to set up bandwidth guaranteed paths, enable ADM switches to act as routers, label distribution protocol. Now this LDP has been getting removed. Because of that, we can use the segment routing for that. That is a different chapter anyway. MPLS operations. 1A, HSC, existing routing protocols, example OSPF and ISIS, establish the reachability to destination networks. The entire MPLS cloud should be running with an OSPF or ISIS. We just need to maintain that. First of all the networks should be connected with a layer 3 connectivity inside the MPLS cloud. Then LDP should be configured on top of it. Then LDP will be form the neighbors between the based on the L3 on this L3 protocols which we configured on that. Then number 2, ingress edge LSR receives the packet. These are all receiving the packet. Perform the layer 3 value added services and labels the packets. Then number 4, edge LSR at the egress removes the label and delivers the packet. In number 3, sorry, I left number 3. LSR switches the packets using the label swapping. Number 1 is nothing but like we will be configuring the OSPF and ISIS on this, either OSPF or ISIS will be configuring. On top of it, we'll configure the LDP to keep all things ready. Then the number 2, ingress router, means like PEs will be talking to the outside and they will be bringing the IP protocol data. Once it is bringing out, they will be putting some kind of a label and they'll forward it. Number 3, they are switching based on the label informations. Number 4, the edge router on the other side, it will be removing the labels and delivering the data to the customer like that. So inside whatever it is happening, The customer doesn't know anything about it. How many routers they are passing, how many informations are getting passed on that, what are the labels attached to that, how they are getting removed. Nothing informations are given to the customers on this. So to not to reveal this information about the customer informations also, we will be using the VPNs. That is called as an MPLS VPNs. We'll see in the next coming slides. Label distribution protocol used to distribute the labels in MPLS network, forwarding equivalence class. How packets are mapped to the LSPs, label switched paths, advertise labels per FEC, reach destination ABCD with the label X, something like that. Then it will be doing the distribution also, discovery also, right? LDP neighbor discovery, sorry, discovery will be done. So neighbor discovery, extended neighbor discovery. Discover directly attached neighbors, point-to-point links, including the Ethernet, establish a session, exchange prefix and FEC, and label informations, extended neighbor discovery, establish PN label relationship with the another router that is not a neighbor, exchange FEC and label information, may be needed to exchange service labels. The LDP will be doing the two kind of discoveries. Then we need to talk about that unicast routing protocols. Routing protocols in the sense, inside the MPLS cloud, whatever the P or PE has been configured, provider edge router as well as the provider router, means of core routers, they should be running an OSPF or ISAS has to be running inside, and BGP should be configured on the edges of it. So they provide the reachability. Label distribution protocols distribute labels for prefixes advertised by unicast routing and protocols using LDP or existing protocols like a BGP to distribute the labels. We will be doing it very rarely, the BGP and all, will use LDP only. And how they are forwarding the packets. This is a small diagram which has been given on this. Number one, the data which is coming in from the address, I can just say for that 128.89.25.4. And outgoing interface is number one. This is the outgoing interface of this router. So this is an blown up picture. I can check it as once it is entering this, outgoing interface is 1, outgoing label is 4. Okay, once it is reaching the core router, you can just say this is a label switching router, something like that. Once it is reaching here, incoming label is 4 because this guy is giving 4, so 4. Same prefix 128.89. Outgoing interface is 0, means it is going via this. Outgoing label is 9. Every router will be switching the label. That's why they are called as the label switch routers. They will be stripping the older label and they will be attaching the new label. By these labels only they will be identifying that how they are reaching the particular destinations. And the label on the third router, we can just say the incoming label is 9 and outgoing, maybe like this is going to be, this router is like nothing but an outgoing, like maybe this guy will be connecting to the customer edge. So he will remove the label and he will provide only the data to the customer. That's what, see, when it is entering, label it is attached as a 4, and it is entering this router, label is attached with 9. When it is entering, label has been removed and the data has been sent on this. So this is a label switch forwards based on the labels. So this is a small example, small diagram which I shown that, and so many routers which are involved on this. This is only 3 routers are shown. Like I can just say this one is like, I say this is a PE1 in our diagram, and this is a PE2. Okay, and this is a P router, means a core router. PE1 and PE2. Izaruddin, can you please switch off your video? Thank you. Izaruddin, are you listening me? Okay, anyway, no problem. So, just putting something at, okay. Okay. I'll keep it on that one. Okay. So now when the packet comes inside the PE1, the PE1 is putting one label on that. Then it is sending it to the P. The P is putting another label on that. It is sending it to the PE2. PE2 is outsider. Outsider in the sense it is going to talk to the customer directly. So when it is going to talk to the customer in the sense it will remove all the labels and it will provide only the data. That's what I was explaining. That's it. Let us go to the next slide. It's like how the MPLS is forwarding the packets on this. MPLS VPNs. Let's see some examples on this. VPN is a set of sites which are allowed to communicate with each other. VPN is defined by the set of administrative policies. Policies determine both connectivity and QoS among sites. Policies established by the VPN customers. Policies could be implemented completely by VPN service providers using BGP, MPLS, VPN mechanisms. That is what MPLS VPNs. We are not talking about the normal IPsec VPNs or something. Even you can do this, MPLS VPNs can be protected as an IPsec, but it is too much of a headache. Anyway, MPLS VPNs provide like L2 VPN is there, L3 VPN we can construct on that. That VPN we are talking about. Next one, what is an L2 VPN and what is an L3 VPNs? L2 VPN is like a CPE connected via the L2, such as frame relay DLCI, ATM VC, or point-to-point connections. If it connects the IP routers, then pairing or routing relationship is between the endpoints, multiple logical connections with one with each endpoint level. Layer 3 VPNs, customer endpoints pair with the provider routers. These normally we do that. Single peering relationship, no mesh of connections. Provider network responsible for distributing routing information to the VPN sites. Separation of routing tables from one VPN to the other. So this is how we will be maintaining the secrecy between the customers, even though they are connecting to the same provider edge router from the same city. Like for example, one Accenture is connecting, another one is Cognizant is connecting. They both are connecting to the Tata VSNL provider edges and other. I can create two VPNs. I can create two VPNs on the same router line. So one VPN cannot talk to the another VPN at all. So that's how their secrecy has been completely maintained. That confidentiality has been completely maintained on that. And the layer 2 VPNs, that's just in like explanations on this. Designate a label for the circuit. Exchange that label information with the egress PE. Encapsulate the incoming traffic, layer 2 frames. Apply the label. Forward the MPLS packet like this. And the egress, look up the L2 label. Forward the packet to the L2 attachment circuit. L2 VPN architecture is like that. VPN A, VPN B is the PE to PE connections. Emulated pseudo wire connection, we normally call it as like a pseudo wire connections on this. Ethernet VLAN, FRDLCA, ATMBC, PPP sessions like this. Layer 3 VPNs are like this. The left hand side, I can just say overlay VPN pushes content outside the network, costs scale exponentially, it's a very heavy cost, transport dependent, groups, endpoints, not the groups, complex overlay with the QoS, tunnels and IP and other things. MPLS based VPNs are like this, multicast, VoIP, hosting, everything is possible. Enables content hosting inside the network, flat cost curve, transport independent actually, because you can connect any media, easy grouping of users and services, enables QoS inside the VPNs. You can do a lot with an MPLS. MPLS cloud, mostly we will be using it like a traffic engineering and all, we'll be using it for voice related communications and all, because we don't want to have any kind of an interruption on the voice communications or something. We will go for MPLS TE connections for that. So we will create our own VPN for this one. And I will be running on this. So this is the comparison between the older overlay VPN and the MPLS based VPNs. Even if you like to create a VPN with your Amazon cloud or Azure cloud or something like that, we just need to go through this kind of steps only. We need to connect with the BGP connections and all. Okay, using labels to build an IP VPN. This is a customer A and this is a customer B. Customer A is connected to is an MPLS connections. Like I can say this is a PE1 and this is a PE2. So PE1 is giving the connectivity back to that inside the MPLS network. They are talking to each other. The customer A is connected on the other side of the customer A. So his packet will be properly configured and it has been transferred to the customer A only. So you can just see this router is containing all the customers packets. Customer A as well as the customer B's packet is there. So we are creating the two VPNs on this one. So customer A's packet will not be sent to the customer B. That's how we are maintaining the confidentiality between the two different customers who are building the MPLS VPNs. Network distributes labels to each VPN. Only labels for each of other VPN members will be distributed. Each VPN is provisioned automatically by the IP routing. Privacy and QoS on ATM without tunnels and encryptions. Another mechanisms of labels for QoS and VPNs, no trade-offs, something like that, it goes on. How does it work? Simple idea. Use a label to designate the VPN. That's it, simple. Route that VPN packet to egress PE advertising that prefix. Use the IGP label to VPN packet to the egress mode. How does it done? Routers need to maintain separate VPN routing tables called as a VRFs. We will create the VRFs, virtual routing and forwarding tables. Routers then export and import routes using BGP extensions to identify and separate one VPN's routes from another. Routers that exchange labels for VPN routes in addition to the IGP routes. So like that it's working. So MPLS VPNs, like a diagram we can just see here. The same thing. See, you see that this PE is having the two customers. One is a orange customer, one is a blue customer, right? There will be like a orange VRF will be created, blue VRF will be created. Then it will be coming into the through the LDP only. They are talking all these things. IBGP has been configured, everything. Whatever it is, the cloud requirement has been fulfilled. So here the BGP is configured, here the BGP is configured. When this VRF is coming up here, the two VRF packets are which are coming up over here. Means like blue VRF is coming, orange VRF is also coming. Only the blue VRF packets will be given to the blue VRF customer. Orange VRF packets will be delivered to the orange VRF customer. This is how we will be constructing the VPNs. Overlapping addresses are made unique by appending RD and creating VPV phone addresses. RD means route distinguisher. Like route target and route distinguisher we will be talking about in MPLS VPNs. RD will be distinguished between the packets between the VRFs on this, customers on that. Control plane paths, it's again very much of a technical thing, so you should understand that, because in a position if you are going to troubleshoot certain VRF is not working properly, some customers are saying that my packets are not reaching, I can't able to reach my customer on the US or something like that. So you should understand this control plane and the data plane, both the things you should be understanding. VPN A, no direct pairing between the CEs. See, this CE and this CE means two customer edges are not having any direct connections at all. They are going through the number of routers which is inside the number of routers which is inside the MPLS cloud. That is what been called as a control plane path. Routing relationship has been maintained. See that. So IPv4 route exchange is happening on this. PE to PE will be connected on it. Then it will be delivered to the CE. This CE will understand how many routes are there in the CE. It's possible, but control plane is completely handled by the MPLS cloud. That's what VPN v4 routes advertised via BGP, labels exchanged via BGP. So this is the extra information about that. Here the data plane path, ingress P is imposing two labels. Routing relationship between these two, VPN A and VPN B. This is the two VPNs they're talking about. VPN v4 routes advertised via BGP, labels exchanged via BGP. Means this router, PE router, is receiving the two different customers' data. That's why he's putting like two different labels on this one. So both IPv4 packets are containing both the colors of it. Once it goes to this, maybe this guy is only for a purple kind of, no, it's like a maroon VRF or something. It goes on this one. The other guy has been out because he's not having any router sources. Means there is no output for this guy. So his ingress is P is imposing the two labels on this. One label has been properly forwarded properly. Other one will be waiting for that to get forwarded on this one. So this is a difference between the control plane and the data plane. IPVPN architecture, VPN membership based on the logical port. There are two customers, one is called as Renault, another one is called as Bangkok. I was explaining something like blue and orange or something. Same thing, VPN A site 2 and VPN A site 3, corporate A site 1, corporate B site 2, corporate B site 3, corporate B site 1. This all connected to this accordingly. So one corporate B is trying to talk to its own corporate B, site 1 and site 2. Site 1, site 2, site 3 would like to talk to each other in the sense they are in different VPNs. This corporate A has got site 2, site 3 like that. They are in some different VPNs. Scalable VPNs. Add more P's if more VPNs are needed. No n n raised to the 2 mesh. Full mesh is not at all required. VPNs are built into the cloud. IPQoS and traffic engineering is possible. Easy to manage and no VC mesh provisioning is required, providing a level of security separation equivalent to the frame relay and ATM. Supports the deployment of new value added applications. customer IP address freedom. They can use any IP address they want. Means both the customers can use same subnet is possible. I can do the routing between them, even though I can do the separation between these two packets as well. So that is what, that is a freedom has been given for the customers. When we configure, we'll understand that. Key features, these are all the features which we already discussed on this. Quality of service is the scalability, has been the connectivity to the internet, we can give it from inside, simplifying the operations and management of the VPN service providers. No constraints of addressing plans by the VPN and the VPN customers. Security has been completely maintained on this, like this. So we come up to the end of this slide, and someone was looking for the information about my YouTube channel. You can just see this YouTube channel, no problem. You can see it on the sleeve. I'm not that case of something is there. So you can just see on this. I would like to show you a small demonstration on this, the BGP as well as MPLS on this. Let me start my GNS3. It may take up some time. We just need to wait for some time, please, so that it'll come up and it'll be ready. It may take some time. I guess all can see my screen now. My GNS3 is booting. It's talking to the VMware. It's a very simple setup, but we require minimum 16 GB in your laptop or something like that. i7, if you have i7, it is very nice. Don't look for any lesser than this because it requires a heavy GNS3 VM is starting. It requires a very heavy memory for this. Unless and until the memory is not there, the routers will not be able to start it on its own. It may take a lot of time for to start that. And because we require to understand the MPLS and BGP by at least configuring 10 routers minimum, so that you will get the full knowledge about that how the packet is getting forwarded in between the MPLS cloud and the other things on all. So it's not so easy that we require at least 10 routers for to configure that. If you are configuring 10 routers, even if you are configuring one router per like in a GNS3 in the sense, we require to have at least 1 GB per router. So 10 GB is required for that. That's what I was saying. So 2 GB, at least 2 to 3 GB has to be given for the, we have to give it for the, what I say. Okay, let me take this. And 2 GB for the Windows and 2 GB for the GNS3, it's required. Let me load this topology. This was I was telling about that, and this is the CE1, is a customer edge 1, and this is the customer edge device 2. The customer edge 1 is connecting to the PE1. PE1 is nothing but the provider edge. Is connecting to the provider edge 1, and the customer edge 2, it is connecting to the provider edge 2. And the provider edge 1 is talking to the P. P is nothing but a core routers, and the P is talking to the PE2, like this. So this entire thing, I can just say this is the cloud, ISP cloud, means MPLS cloud, I can just say. So he is a customer 1 and 2. So these customers will not understand what is a BGP, what is a BGP running, or whether it is running with like any kind of MPLS running on this. Nothing they will be understanding on this. So that we are completely giving the freedom for them, how their packet are getting forwarded, and how effectively they are able to reach their own network on this, how fast it has been happening on this, and whatever the locations they are going to have it on this. Like, yeah, somebody is clicking, chatting. Can we have some lectures in small chunks? It might be difficult to understand all in single day. Okay, see, this is like I given this topic as like BGP and MPLS. That's why I just made it like. So you can even suggest me like what are the topics you would like me to discuss it on a day, something like that, single day. Then I will be going with that one, like, because. So Mohammed was asking like that question. Nice question. Okay, because it is like, because I combine it like a BGP and MPLS, right? So that's why I'm talking both the things on this now. I definitely will do that. Not an issue. Okay, now, so this is how the things are coming. So now I am configuring the RIP version 2. RIP version 2 is older. Nobody is using it, but for our laboratory purpose, I configured the RIP version 2. Then I will be starting, let me start this routers. If I click this green button, everything will get started on its own. It may take up some time. We need to wait. So here, everything will be becoming green here. Okay, so it's taking time. So now my CPU has gone to 93. So once it has been settled down, we will be able to see console to these routers and we can verify how the packet forwarding is happening. What is the forwarding table? What is the SIF table? What is the routing table? And how the BGP connection has been made on this. We can check each one by one of them. Please wait until the routers are getting settled down. Now it is an 18% something. So it will come up, don't worry. So because I just configured very minimal thing, but we will be seeing a many multiple scenarios as well on this. Not a big problem at all, but because this is a group session, so I made it like a very simple one. Can't give it on everything on a one single day. So as for the other person has said that you are trying to take everything on a single day, like so it's okay. But as far as the concern, like because I just need to show some kind of a practical so that you will be happy to see something like rather than just talking and just going on with the slides or something. So many people are giving slides and other things, like you can download a lot of things from the internet itself. So let me start all these routers. I'll just click on this icon so that we'll be starting all the console for the routers. They are coming one by one. It's a CE1 has come. Yeah, CE1 has come. Please share recorded session. Definitely I will give you. Don't worry. Definitely I'll give you all the recorded sessions. Okay, okay. So PE2 has been ready. Now here's a CE1. This is CE2. And this is P router. And this is should be the PE1. And this like that. So every router has got some kind of, we just seen the console of them all. So here it is a console. So let me show the CE1 first. What I configured on the CE1. Show IP interface brief. I'll do it. It's a fast Ethernet one which I configured with this one and the serial, and there is one low back address also been configured on this. Sure, an interface FS00. So this is with the 24-bit mask. It has been configured, and serial I can show it to you. It's a 8-bit address I configured. So now I configured with like let me configure it like route begin router. So here the RIP has been configured on this. It's a RIP is a older one. I'm using the version 2. I advertised all the 3 networks as well, 4, 10, and 172.16. So let me go back to the CE2. I did the same thing here also. Show IP interface brief. Show an interface FS00 like this. So this is a 24-bit 172.16 2.1. There I configured 1.1. Show an interface 10 like this. So this is 11.112 I configured. show run include router. Sorry. Show run. Let me see. Begin with router. It'll show. So now it is also router RIP has been configured. Both the routers are configured with the RIP. This is also configured with the RIP. This is also configured with the RIP. So they try to exchange the routing table between through the MPLS cloud on this, right? It's a very simple practice on this. So let me go back to the P router. In the P router, what are the configurations? I'll show you. P router, I just configured like IPsef has to be configured as a first step to configure the MPLS packets to run on. And the protocol I'm using that it is LDP. So there are in the P router, I have two interfaces connected. Fast Ethernet 00 and Fast Ethernet 01. You see that 192.168.1.1 MPLS IP, 192.168.2.2 MPLS IP. This need to be given. There is a loopback address has been configured. So there is a OSPF which has been running on the entire cloud. This entire cloud in the sense these all three P routers should be running with the OSPF. So I can even show you the OSPF neighbors here. Two neighbors are there for P, definitely. Is a 1 and 3. It's showing 3. Then if you'd like to see the database of the OSPF, you can check it here. Like this is the database, 1, 2, 3 has been there perfectly. And they are in same area only. Then show IP route, if you see there are some overroutes only, you'll be able to see that. You can't see anything like MPLS count, MPLS things are running on this. Let me go back to the PE1. PE1 is nothing but which is connecting to the CE1, means like this customer, first customer is connecting to the first P. So here, show running, let me show. Here I have created the VRF. So for example, the VRF name I given like an AMDoc. You can give any name you want. That is an AMDoc is a company like that. Take it as MPLS protocol like an LDP which I configured on this. And RD, that is nothing but the route distinguisher. Here the loopback address has been configured. See, you can just see that MPLS IP means or whatever the MPLS configurations has been done only on inside edge of this, means which is talking to the P router only. There I configured the MPLS IP. I did not configure anything on serial. MPLS is not configured on serial because it is an outgoing. Okay, and as usual I configured OSPF on this. Then RIP has been configured, right? RIP to talk to the outside because this guy need to talk to the RIP. He will be doing the RIP calculation. Let me write down here. He is configured with the RIP, LDP, sorry, not LDO, it's an LDP and OSPF, then the BGP also. Like that, somebody is pinging. Also, I get the invitation from one of my friend. It will be appreciated if I can have direct group or way communication to interact for each sessions. Definitely, you can join my group. I will be giving you my group ID. Okay, you can join there. In a WhatsApp, there is a group called Ramnet is running. I'll give you the invite for you, no worries. Okay, at the end of the session, I'll give you the invite. You can join to that. Okay, now, so I have configured all these protocols on this PE1, so it should be configured. And the same way I configured in PE2 also. Yeah, thank you, thank you. Okay, so here we will see that the same thing. Show running, let me show. So IPsef has been definitely should be configured, definitely. Okay, same IPVR of AMDoc has been configured because we are talking through the only one customer on this. So here is the route distinguisher and route target has been configured. Serial doesn't contain any kind of MPLS informations, right? And only the FA01 is configured within MPLS information. So here I configured the RIP with the address family. OSPF has been configured for internal communications. BGP for exchanging the labels and to creating the PS, and they will be talking to that. Address family VPNv4, IPVRF, like that it has been configured. So once, if you would like to see, this is the configuration between all these things. So if you'd like to see the how the connectivity has been maintained, like say IP OSPF neighbor, if you say this neighborship has been made with the P router, show IP BGP neighbor, or if I can just say show IP BGP summary. This BGP summary, this 111 is nothing but the PE1. they are established the connectivity on this. Show IP BGP table, if I see, it will not be showing anything because everything is being given inside the VRF only. Okay, then you can just say IPv4. I just need to do IPv4. Then I can do the unicast. Then I can do all. Oh, sorry. Let me show the other commands also. Then it will be easy.
Hi, can you please tell me what is the address family?
What is the addressing?
Address family.
Address family is like
Address
you
family.
need to configure that so that it will be talking to the customer properly. Address family is the only thing is it is going to talk to its own peers on this. This BGP 111 is nothing but we configured it in PE2, right? This is we configured it in PE2 on this. This is going to be the PE1 router where we configured like a remote AS1 is a autonomous system which is configured on the PE1 on this. And this is for a VPN we are creating. For the customer network canal, we are creating the VPNs. Under the VPN, we will be configuring this kind of VRF we are configuring on. So there is a lot of things need to be discussed on this, but the time is very short, so I'm not explaining. So it is like a demonstration only. So I'm just doing that. So now we are distributing
Okay,
the
no issues.
redistributing the RIP to this. Yeah, we are redistributing the RIP to the RIP is the packet which is coming from the customer edge, and I am picking that information and I am redistributing it to my neighbor. That neighbor will be understanding this. Means through the BGP, through the BGP, through the BGP connections, this RIP information will be passed on to this. That's why it is called as an MP-BGP. So this AMDOC, VRF, whatever the connections are there, whatever the networks are there coming from the CE2, through the VRF it will be transferred back to the PE1, and the PE1 will be sending it towards the CE1. The CE1 will be having all the information on this about the neighbor who is being connected on the other side of it. Like that, we can just check this, and I would like to show something on MPLS. MPLS forwarding table. This is like a label information on this. Label local tag, outgoing tag, prefix, bytes switched, outgoing interface, next hop will be showing. This is the tag numbers which are coming, like this is a local tag. Tag is nothing but the label information, label number 16, number 17, like that it will be given. Start from the 16 only, it will be going on. And what all the prefixes are attached with what tag, it has been shown here. What is an outgoing interface? Mostly it will be FA01 only, because this is what has been connected to the P router. And serial is nothing but a point-to-point connections on that. If you'd like to see the show MPLS LDP neighbor, it will be showing the LDP neighbor. LDP neighbor will be the P router only. Number 2 will be the P router. And LDP discovery, if I do, it will be showing the transmit and receive. If it is transmitting and receive, the labels are properly switched. Like they are receiving the labels as well as they are forwarding the labels also. Either I can just check that. And I can just go to the show IP routing information on this. It's an O route we are getting it. So similar information I can get it from the PE1 also. Show MPLS forwarding table. This is the same information how the PE1 is assigning the labels to the each and every prefixes which is receiving or sending it, like all incoming and outgoing. 16 from 16 only it is starting on this, but outgoing will be something different on this. So MPLS forwarding table, then I can just say MPLS LDP neighbor. So this is like 222 is again the P router is a neighbor for him. Then the discovery you can just check that. Transmit and receive, it is doing the transmission. Local is 1, remote is 2. It's showing like that. In the P router we can check that. This is a central router which is not doing any kind of routing or something like that. It will be doing only the label switching on this. Show MPLS forwarding table. It will not be showing anything at all because it doesn't do anything like that. It will just forwarding things and all. Show MPLS LDP neighbor. Sorry, MPLS it is. There are two neighbors are there. One is a neighbor 1, another one is a neighbor 3. This is P1 and this is P3. So local neighbor is nothing but a 2, like that it goes. Then discovery check. transmit and receive. 1 and 3 is been doing the transmission as well as receiving. Local is 2. So like this is how the informations are passed between. Now let us go back to the CE1. Show IP route. Here is see that. This 5 local, what are the local interfaces are there? Let me show you. Local interface is 44, 10.1.12, 172.16. So you just see this. There is a remote route which is coming up. RIP route learned, and the RIP route learned 172.16.2.0, and the RIP route learned 5550. This is coming from the other side. If I do the tracing, if I do the trace of 555, it will be showing you the entire MPLS path also. Either it is taking to the 10.1.11, then it is reaching to the 192.168.1.2, then it is reaching the 11, this is reaching the 11.2. This is nothing but 10.1.12, something like that it is going, right? 10.1.11 it is like that. Then 192.168.1.2 it is taking. Then it is going to the 11.1.1, this way, 11.1.1 it is going. Then it is getting reached to that. Like that I can do. I can do it from the CE2 also. Show IP interface brief, I will show you. So this is the local information. I will show you the remote informations also. So 4 is learned from the CE1 through the MPLS cloud. Let me trace 4. It's going same thing through the 2.2, 10.1.1, 10.1.12. It is reaching the other way like this. This way it is reaching on this. So like we will be able to multiple customers as well. I can even connect one more router. Please mute your mic. I can even connect one more router here. Right. I'll take one more router here, and this router will be connected to this PE1, and another router here, and it will be connecting to this PE2 like this. So this will be the customer edge. I can say this is customer edge 3, and he is a customer edge 4. I'll be creating the different VRF for this. So currently I created the VRF like that MDoc, something like the name I given. So another VRF I'll create it like an Accenture, like that I'll just do. This piece will be keep on separating the traffic between the two customers because of the VRFs are differently configured between them, so that they will be able to reach their own customers as well, and they can transfer their packets as well on this one. It's possible. Or if you would like to share the packets between the customers also, between the VPNs also, we would like to do that. We can also do it. That is like because their own customers. If, for example, if it is an Accenture, is a customers or 3 customers are there. All the customers are connecting to the Accenture VPN in the sense. In the Accenture VRF, we can able to redistribute the VRF packets between their customers also. That is also possible on this. So, but we just need to take the confirmation from the customer to exchange the routes between the customers within the different VRFs also. So like we can keep on doing many things on this one. Okay. So this is about the small explanation which I given you today. And if you have any questions, you can ask me on these questions. It's like a question hour. I can just make it out like, or I can just do the chatting, and you can ask me any questions if you have any queries on like any kind of certifications or like Cisco, any technologies. Anything I'm open to you because I just discussed today the BGP and MPLS, not so heavily because we need to cover a lot of things. We don't have time for that.
Hi, Ram.
Yes.
Dinesh here. First of all, thanks you for a wonderful session. I have 2 queries over here. One is in demo in MPLS broadcasting, able to see MPLS tagging, tag labeling tag, correct? But it is automatically generated tag.
It's an automatically generated tag. If you don't hello. So if you don't configure it if you just leave it like that, let the labels to make on its own. Otherwise, we can even impose the labels also. It is possible. It's manually configured. We can even set the set of labels for certain customers itself. We can make them. It's possible.
Okay. based on the labeling tag in troubleshoot point of is make any use or
Definitely, by seeing the labels only, we will be able to identify that which customer is not reaching properly, which customer is not able to reach his destination properly because of the labels are missing, or they are being dropped somewhere, or they are get confused, or they may be like due to some lack of the layer 3 informations, or the set table is not properly like properly calculated or something. Through the labels only, we'll be able to identify the problem. The MPLS network is based on the label information only. That's why it is an MPLS, label switching. That's why we call it
okay,
as
fine.
multi-protocol label switching.
Yeah, got it. Yeah, got it.
But
And
what,
yeah,
go.
Yeah, please go ahead.
Yeah, what they're doing that they would like to remove this LDP because LDP is quite nowadays it's started doing some kind of vulnerable things and all, or they are feeling that LDP is not so doing good or something. So they started coming up with like a segment routing on this. So that is a different chapter also. So yeah, you can ask your question now.
Yeah, my next query is in MPLS router we configure CEF, and another thing is in interface we have to enable MPLS
Yes,
IP, right?
yes.
What's the difference for CIF or the
IPsec is required. IPsec is required when configuring it in Cisco routers. If it is a Cisco router, you should configure the IPsec. Then only the MPLS will work in Cisco routers. And the MPLS IP is nothing but that particular interface is capable of exchanging the MPLS informations, labels, and other things. That MPLS IP is required. That MPLS IP, the command is not configured if it is that interface is customer facing. That is the difference.
Yes, okay, thank you. I got it.
Yeah. Any other queries from anyone? You can ask me because it is very simple, very not simple, but you can ask any questions about the courses or something like that. What timing or something like that you can ask me, And this BGP is very much required, so it can go ahead with MPLS. Should be going ahead with the courses like that. BGP extensive BGP learning is required. Then only the MPLS can be conducted. The BGP plus MPLS plus QoS also we need to see that. MPLS traffic engineering is also there. I can think of taking up that in the next session or something. Traffic engineering is also one of the good options. So that is like a feature activation inside the MPLS cloud. Something we can see that one. Like so, when you're coming for the sessions or something like that, I'll be conducting all these things. Yeah, thank you. And it's I'll be conducting the BGP, IGP basics and other things like BGP configuration, IBGP, EBGP, and attribute configuration, communities configurations, peer grouping, confederations, router reflectors, everything will be doing that. Later, then we'll come back to the MPLS because MPLS is a very bit compared to the BGP. MPLS it doesn't take much time to learn, but it requires rigorous practice from your side. But if you know the BGP very clearly, MPLS can be understood so easily because MPLS depend on MPBGP, means BGP is depend on BGP. And overall, you should be having the operating system knowledge and the routing protocol knowledge is required. Minimum, if you worked around 3 to 4 years on the network side, core networking. I'm not talking about like system administrators, no, not a system administrator. You should be a network admin guy who has been worked on routers and switches, any branded. Cisco only is not required. Any branded, if you work down, it's nice because BGP knowledge is required. MPLS and complex network knowledge is required so that you will understand. And ISPs, people are definitely they are working along with an ISPs only. So then only you will be able to understand the MPLS. How does the cloud has become? How to distribute the labels? How to distribute the multiple customers with one VPN? And how do you make the communication between the different VPN peoples? How to separate the VPN? How to create the traffic engineering on this? So it requires rigorous practice because it is a completely command based, and we are not to write everything on a commands. We just need to understand this. We need to byhead the commands by practicing it only. It's not like GUI, just go ahead and go okay, cancel or clicking radio buttons. Those are not possible in MPLS. We just need to literally configure by the hand. So it'll take like heavy time for you to understand this. But the session can go for a month or something. If you come for MPLS plus BGP or something, maximum a month we can see that. And the CE protocol we will be seeing like I shown you like a C means a customer edge is configured with a RIP. So I did the MPLS cloud to do the routing for a RIP protocol. We can do the EAGRP, we can do the OSPF, we can do BGP itself, and we can do ISIS also. So we will be seeing the different scenarios inside the MPLS clouds, how the CE protocol, different CE protocols are getting carried inside the MPLS clouds. Like, so we can see that also. So, and moreover, I would like to have your people's like email addresses, at least if they're not numbers. If numbers are, you are very much shy to give the numbers or something, telephone numbers is not good. Okay, leave it out. At least the participant list, I would like to create it so that I can give you this recordings and the PPTs to the people in first shot. So if you can paste it, your email addresses on the chat box will be very nice. Please do that. Yeah. And Dinesh is given. Yeah. Abdullah is given. Okay. Okay. Please give everyone, please. I was just seeing that many people are there. Please type it out. Not a problem. I will not be disturbing you at all. I'll give you this, like this PPDs. I'll give it to you. Some recordings. I will pass it on to you. Or forthcoming sessions, like whatever it may be, I may be intimating you directly. So you will not be, you don't need to go through any groups or something to get the details or something. Definitely, I will be sending you this all details to you guys. Don't worry. Personally, I'll send it to you. Please make my name not go to the spam or something. Okay, in your Gmail addresses. So I like talking to the peoples because I try to share my knowledge with all the peoples as well. So every Sunday, as of I said that every Sunday morning, 11 o'clock IST, Indian time, I will be talking on any subject, any one of the technical subject I will be talking. I used to deliver it for a FI also. Somebody was asking about FI. FI on local traffic manager, global traffic manager, as well as application security manager. Everything I do. Okay, now I am preparing myself for Nginx. Nginx is also been acquired by the F5. So Nginx training is also I am planning for that. And I'm planning for Kubernetes and other things and all. So I will be giving you latest information about my trainings and sessions and the latest uploadings to the YouTube sites, or if any new slides which I made, that I'll be giving you all this information to your people directly. So thanks for giving all the addresses. Thank you very much. And okay, please give it, everyone. Guess everyone is given. 1, 2, 3, 4, 5, 6, 7. Okay, as of everyone has given it. So if you don't have any more questions and all, we can go ahead and just close this session because it is crossed 1 hour. If it is crossing 1 hour, I may be having some little bit of difficulties in uploading it to the YouTube. That's why. So if you have any personal questions from your side, you can email it to me. The number is there in my, you can even call me on this number. You can WhatsApp it to me, or you can just email it to me. I will definitely answer you back. On all my videos will be available. Every other session, it's available on this channel, Ramnath K. So you can go and see it. It's a free channel. No need to pay anything at all. And you can watch that one. Yeah, thank you very much. Thank you. So let me go ahead and just close this meeting. Thanks for joining all people. Thanks all. Bye. Have a wonderful day. Have a wonderful weekend today. Okay, thank you. Bye. Okay, then I stopping the sharing. Then I'll be ending up this meeting.